In this video, I'm going to discuss thematic mapping. So if you remember from before, there are three types of maps: navigation, reference, and thematic maps. But this lecture is just focusing on thematic maps. So I'm going to go over chloropleth, choropleth, isopleth, proportional and graduated symbols, dot density, cartograms, and series. Choropleth maps use a mixture of shading, coloring, and symbology to show the differences between values of a variable or variables and their spatial relationships. The CDC had quite a few good examples in one of their cartography manuals, so many of the maps will be from that document. As we go through this slide, I will occasionally give my personal feedback on the map in order to help you learn how to look at maps more critically, whether that's a map you make or a map somebody else makes. I would like to preface this by saying that no map is perfect, and many things about map design are subjective because it's still a form of art, just in combination with science. So, this map shows the number of AIDS diagnoses in the US in 2009 at the state level. And this particular map, my primary issues are the legend and the title. And to be honest, the more I look at it, the more it bothers me. So, I apologize to whoever made this map. I'm going to assume it's something you just threw together to show the differences in map types for the guide that it came out of. That's more work than I did. Anyways, back to the critique. In the health and medical sciences, people with a specific disease or medical issue are called a case. Now, as we talked about before, when we are comparing aggregated quantitative characteristics of different objects, whether that object is a state, county, or something else, we need to normalize. Normalizing is what makes the data comparable to one another by creating some form of a rate. If you were trying to compare two drive times, you wouldn't just say two. Two what? 2 miles, kilometers, feet, minutes, hours, seconds? No one knows except for you. And that's a huge problem. And that's something we will discuss more at during our next live discussion. Hint, hint. But as far as I can tell, they did not normalize their data. I'm going to assume the quote unquote number in the legend is the number of cases. And I hate to bog you down with more terminology, especially terminology that you don't need, but it's necessary for this example. Disease prevalence is the percentage of the population that has been diagnosed with a disease. Disease incidence is the number of new cases or new diagnoses of a disease. I don't have much knowledge about the numbers of cases of AIDS in the US, so I have no idea what this is representing. So not only is the map not normalized, but we don't even really know what the actual numbers are representing, besides the number of diagnoses. That information could have also been located in the title or notes, but it wasn't. What additional information was given in the legend is that the groups were classified into quartiles. Unfortunately, that little piece of information was easy to overlook if you were just giving the map a quick glance. What I would recommend doing instead is changing the legend title to something like the number of cases and then in parentheses quartiles. Also, I would like to know if this is prevalence or incidence, but that's me. I'm assuming it's prevalence. So here we have an isopleth map. Isolines are lines of equal value. These are created when you have point data that has some value, whether that is pressure, temperature, rainfall, etc. And you want to create a continuous surface. So you draw lines that are between points of equal value, and you want to draw the lines at distances that are proportionate to the differences among the values. And I have a quick video to show you to hopefully help you understand how isopleth maps are created.
Okay, drawing isolines. Okay, we have a field map here, is what that's called. And let's first think what an isoline is. An isoline is a line that connects points of equal value. So you're going to estimate um, where equal values are here, and we're going to draw some isolines. So first, let's just do this one. Let's do 70 first. Okay, so we have this map here, and we want to draw a line. Everything, wherever in the line is about 70. So let's find a place to start. It is always nice when there is an actual dot that has the exact value. You're looking for, in this case, 70s right here. So this is the way I teach it. You're here, okay, and your question is, where's the next 70? And if you look around here, there's not another dot that is exactly 70, so you need to estimate. So where is the next 70? Is 70 between these two numbers here, 73 and 74? No, it's not. That's too high. Is 70 between 74 and 74? Nope, those are too high. Is 70 between 74 and 73? Nope, so I'm not going there. Is 70 between 73 and 66? Well, yes, it is. So draw a dot right there and then connect it to that. So now you're here trying to figure out where the next 70 is. And you're just kind of looking in this general area here. Don't look out here. So the limit's where you're looking right here and say, where's the next 70? Is 70 between 63 and 69? And no, it's not. Those are too low. Is 70 between 69 and 73? Well, yes, it is. So it's right there. So now you're going there. So now we're here. Where's the next 70? Is it between 73 and 75? No, those are too high. These two numbers here, too high. Is 70 between 69 and 72? It is. So now you go here. So I call this like a stepping stone method. You put the little dots and you kind of just jump to the next one. So you're only just looking in a small area, and it really helps people draw these. So now you're here. Where's the next 70? Is between 69 and 68? No, it's not. Those are too low. Is 70 between 68 and 71? Yes, it is. Put a dot, connect it. The next 70, is it between 71 and 72? Nope. Is it between 67 and 72? Yes, it is. And then you can go to there. Now, you're kind of down here. You don't see any more 70s. These are too high, too low. Let's just try to finish it, because you can't leave it. You can't ever leave them hanging. So 70 from here. Where's the next 70? Is 70 between 71 and 68? Yes, it is. So now you're here, and you're close to the end of the map. One key thing about isolines is you need to, they can't leave them hanging here or here. So in this case, we're going to just kind of estimate and just go off the map, and we'll do it there. It's one of those, it's a very important point that often some of the people forget about. So that's our 70 line right there. Okay? Now, what I'm going to do is let's draw the 85 line. We're going to jump. Let's draw the 85 line. The 85 presents a unique challenge in that you want to start 85. You say, okay, it's probably up here somewhere, but there is no point that is exactly 85, and that leads people sometimes to be confused as to where to start. But all you need to do is estimate where 85 might be. Let's pick a spot. These are too low here. Is 85 between 81 and 83? No. 85 is here. And you can start anywhere that's 85, but I'm just kind of chose there. And then, so where am I going to go from here? Let me see if I can go to the right. Is 85 between these two? No, it's not there, too high. Is 85 between 87 and 80? Yes, it is, so I go here. Okay, and let's go back so we can't be hanging here. Is 85 between 81 and 81? No. Is it between 81 and 83? No, that's too low. Is it between 81 and 86? 85 is. Put a dot there. And then is 85 between 82 and 87? Yes, it is. You go like that, and again, can't leave it hanging, so we're just going to go off the page there and off the page there. Okay? So the little dot method and the stepping stone method really works. Let's just show you another kind here, and we're going to do we'll do the 40 right here. We're not doing 30, we're doing 40, so let's find a place to start. Luckily, there is a 40 here, and everyone likes starting there, which makes a lot of sense.
Okay, so if you want to watch more of that video, I will include the link in the notes. Going back to the presentation. So moving on to graduated and proportional symbols. So graduated and proportional symbol maps both have symbols that vary in size based on their relative quantitative value, usually from the magnitude of an event or phenomena. This is most often with the cases of something. So in this case, it is the number of AIDS diagnoses in the US again in 2009. It is graduated and not proportional because the symbol is broken into four different categories. If it was proportional, then you, instead of having those four different squares in the legend, you would have one symbol from 7 to 100, and then the largest symbol from 701 to 4,799, and then everything in the middle uh, would be drawn in the map relative to their value within that range. Dot density maps are maps that have a certain number of points, usually per polygon, that indicate the number of events or occurrences. So here, the dots are randomly distributed in each state, uh, and they represent the number of cases. So the more dots in the area, the more cases. But please do be careful if you create one of these maps to not uh, overlap any of your dots because it makes it harder to analyze. Also keep in mind, in the bottom right of the map, you can see that one dot is 20 new diagnoses. So make sure that the number you are representing is in fact accurate. You may be able to tell that I'm not the largest fan of dot density maps. Okay, so cartograms are maps that are either uh, misshaped and their states are the objects are changed in size and shape depending on the value of the variable for that object. So in this map, in the top, that's just a regular choropleth map, and in the bottom, you have the cartogram. So you have you have obesity by state. So you can tell that states like California are much more obese than states like Washington and Oregon, just above it, because the percentage of obesity really expands the shape of California and it kind of makes the percentage smaller in Oregon and Washington states. But this is not the only way you can create a cartogram. So this particular cartogram was created by some algorithm that altered the shape of the US states. But instead of having this state of the shapes changed, instead you can represent each state with a circle or some other shape. And then, just like in the proportional and graduated symbol maps, instead of having those symbols uh, above the base map, which then would be the outlines of the US states, you would just have those objects. So it would be a map of circles, and then the circles would be drawn in proportion to the amount of cases, or in this case, the percentage of obesity prevalence per state. And I have decided, in light of the election and their nifty maps, the New York Times has some pretty cool maps. There are four different kinds, so I will allow you to write a paragraph for each one. Each paragraph that you write is going to be worth 5 points extra credit. So I need you to identify the type of map that it is, what it's representing, how it's representing it, and what that map is insinuating. Also, please include a screenshot since the numbers are going to change. Hopefully, it will end shortly. I feel like this election has been going on forever, trying to get the numbers. but definitely include screenshots so that I know that you actually looked at it. And then submit that in your reflection along with any questions that you have for this week or any feedback for me. All right, last but not least, we have map series. So, map series is just what it sounds like. It's in this case, it is Georgia counties that are representing the number of pregnancies among girls that are aged 10 to 17, and they have separated it out by, say, 5-year period and race. So the first row is white non Hispanic, then you have black non Hispanic in the second row, and then Hispanic in the bottom row. And then the time becomes more recent from 95 to 99 on the left, and then 2005 to 2009 on the right. And that way, not only can you compare race by um, the different columns, but you can also compare how the rates change by race over time. Pretty nifty. So, white non Hispanic females have lower rates, while, let's see, black non Hispanic also have lower rates. And I'm not quite sure. I think over time, oh no, they do have the averages. um, so then over time, Hispanic girls ages 10 to 17 have also decreased in rates. What's interesting with Hispanic girls is that they, for some reason, increased from 2000 to 2004. If you are comparing the different races, you can see the black non Hispanics have the highest rate, while whites have the lowest rate. In 1995 to 1999, and then in 2000 to 2004, Hispanic girls from age 10 to 17, followed by black non Hispanic and then white non Hispanic. And then the most recent time frame from 2005 to 2009, white non Hispanic females have the lowest rates, followed by black non Hispanic and then Hispanic of all races. So these are pretty cool. But also make sure that you note here in the legend that the numbers are consistent. So they don't have a different legend for each map. All of the rate colors are exactly the same. That makes it much more easy to interpret. That's all for today. Have a great week.